Hey guys. So today we're going to be talking about proportional relationships, and we're going to be on page 177. So, on this page, we have a scientist. They're using a tracking device to measure just how fast a blue whale can swim, and it says right here that they swim at a constant rate for 5 minutes, and they covered 2.5 miles in that time. So we're going to make a graph showing that change, and then we're going to figure out how far can it swim in 1 minute. So I've kind of started setting up our graph down here. Time is going to be our x, and then miles is going to be our y. We'll talk more about independent and dependent variables later, but just know for now time is going to be our x and miles is our y. So the next thing we're going to do is we're going to label our graph, our grid lines. So we have to get up to at least 5 minutes, okay? In our story, it says we got to go at least 5 minutes, so I'm going to go just 1, 2, 3, 4, 5, and we'll go on a little further, all the way out to 10. And then for our miles, we'll just go up. We'll say every other one is worth 1. So skip 1, 1, skip 1, 2, skip 1, 3, skip 1, 4, and skip 1, 5. All right? And then obviously we have 0 down here. So kind of the way that we would start this, we would say, if the whale swam for 0 minutes, how far, or he didn't swim at all, how far would it go? Well, it would go 0 miles. So I'm going to start with a point right there. And then we also know that in 5 minutes, it went 2.5 miles. So I'm going to go up. There's 1, there's 2, and then right in between is 2.5. So right there. And then I'm going to go ahead and connect those points. I want you guys to get used to using a straight edge when you're connecting. So you guys all have IDs now. So that has a nice straight edge on it. So we can use that to draw a beautiful straight line. All right. So then we have our graph that kind of shows us all this data. And then the second question there is, how far does the blue whale swim in 1 minute? So there's a couple ways we could do this. We could go to our graph and we could say, all right, in 1 minute, and then go up and see where it crosses. Well, it crosses right here. And that point would be at 0.5. So the whale swims at 0.5 miles per hour. Okay? Another, miles per, not hour, miles per minute. It would swim 0.5 miles per minute. Another way that we could do that is we could say, all right, if we want miles on, we would put miles on top because it's miles. So he swam 2.5 miles in 5 minutes. If we do our miles on top, miles per minutes, that's going to get us the exact same thing. It's going to be 0.5 miles per minute. All right. So we got our graph, we've got some data that we've extracted from the graph, so we're doing awesome. All right, so then we're going to flip to the next page. On the next page, page 178, we've got some questions that align with this. How far does the blue whale swim in 1 minute? So this one is a little different. We kind of have to, actually, no, because we just figured this out. We just said he swims 0.5 miles per minute. So in 1 minute, this whale is going to swim a half a mile. So we would just say 1/2 of a mile. And how do we get our answer? We could look back on the graph. We could do our miles per minute. We could do that. All right? So, then we've got this here. This table and graph represent the speed of a different blue whale over a period of 5 minutes. So we've got a table, we've got the graph that we can look at to get information. So letter A just says, what is the unit rate for this proportional relationship? So unit rate is basically when our x value equals 1, at least when it's a proportional relationship. So what I could do is I could go, like we did on our first graph, I could go to 1 and then I could move up and go over, but you'll notice that this one doesn't really end, like cross at a nice spot. Like I don't know what that is. So what I can do instead is I can come over here and I can say, well, since time is my x value, like it says over here, I could say, well, since this is 1, this right here is my unit rate, okay? So my unit rate is 0.4. And what that means is the whale swims 0.4 miles every minute. All right? Because unit rate is like per 1. So he swims 0.4 miles every minute. All right? Part B says the point 2.5 comma 1 is also on the line. What is the vertical change? Okay, so the vertical change is how much we go up and down. And between this one and 2.51 and 5.2, what is the horizontal change? So vertical change is y. So we want to look at our y values for vertical change. So my y value goes from 1 to 2. So the vertical change, so vertical change just equals 1. And then our horizontal change so that's going to be, horizontal is our x values. So horizontal change is going to go from our 2.5 here to 5. All right? And then, so that would be a 2.5 change if I subtract those. 5 minus 2.5 is 2.5. So our vertical change is 1, our horizontal change is 2.5. All right, next. So letter C says the unit rate for proportional relationship describe the rate of change between the variables. Okay? The rate of change is the quotient, okay, so we're doing some division when we find the rate of change, of the vertical change, or the y variable, and the corresponding horizontal change, or the x variable. So the way that we could write that is we could say that unit rate, and I want to make this clear, unit rate for proportional relationships is y divided by x. Okay? So let's use our answers to problem 2b to find the slope of the line between these 2 points. So our horizontal, or our vertical change is our y. So our vertical change was 1, and our horizontal change was 2.5. So that would be our unit rate. Or if we wanted to, we could use our calculators and we could write this as a decimal. We could do 1 divided by 2.5, and we would get that our unit rate is 0.4. Okay, so either of those would work. You can see up here that it matches what we had in our table, but just know that when we do y divided by x in proportional relationships, we should get our unit rate there. So then, letter D just says compare your answers to problems 2A and 2C. How does the slope compare? Oh, hey, that's what we just talked about. The slope is the same, right? We've got the 0.4 miles every minute. We've got the 0.4 miles every minute. So these are exactly the same. Exactly the same there. All right. So then our last little thing we're going to talk about here is reflect on what we've learned today. And it's just how can you find the slope of a line on a graph? And another way that might be better for what we do in the future is we would say change in y, or let's say vertical change, over our change in x, or over our horizontal change. Because when we get out of proportional relationships, we use this kind of terminology just a little bit more. All right? And then that's going to be it for today, guys. Thanks for watching.